In this section, we discuss two time series smoothing methods that are best applied to stationary time series. Recall, stationary time series are time series without significant trend, seasonality, or cyclicality. They exhibit primarily only a random component. Both time series smoothing methods can be used to generate two series. Both of these series are used for different purposes. The first, the centered smooth series, provides a better overall impression of the time series behavior by removing some of the random fluctuations in the actual series. The second, the forecasting series, provides a next period forecast value. This screencast discusses the smoothing method known as moving averages of L periods in length, where L is a positive integer like 3 or 5. Let's go directly to an example where L is 3. We've moved to the next page. This example involves moving averages of 3 periods in length. This is called an MA3 model. We assume the data was collected over 15 periods, and column A identifies the period. Period 1, period 2 through period 15. The actual time series data appears in column B, and in this abstract example is indicated as Y1, Y2 through Y15. Column C contains the centered smooth series values. The first centered smooth series value is the average of the first three actual series values, Y1, Y2, and Y3, and the first smooth series value is identified with period 2 in the center of the 3 periods being averaged over. The second smooth series value would be the average of Y2, Y3, and Y4, and would be identified with period 3. Following that pattern down this column, the last centered smooth series value would be the average of the final 3 actual series values, and the final smooth series value would be identified with the 14th period in the middle of the 3 periods being averaged over. A time series plot of the 13 smooth series values in column C would appear similar to a time series plot of the 15 actual series values in column B, except the smooth series would have less period-to-period fluctuation. In column C, the original series has been smoothed. Note that the centered smooth series values in column C have two lost in quotation marks values. There is no centered smooth series value associated with period 1 and no centered smooth series value associated with the final period, period 15. Column D would contain the MA3 forecasting series. The MA3 forecasting series values are obtained by moving the column C entries forward 2 periods. So, the first MA3 forecast value would be associated with period 4, and that first MA3 forecast value would be the average of the first 3 actual series values. Following this same pattern down column D, to the final entry in column D, we obtain the MA3 forecast for the period after the original time series ends, that is for period 16. We note that the 1 period ahead forecast is just the average of the final 3 actual series values. Column E contains the MA3 forecast errors. The first period with an MA3 forecast is period 4, so period 4 is the first period with an MA3 forecast error. Forecast errors are computed as residuals are computed as the difference between the actual series values and the forecast series values. There's the first MA3 forecast error. Following this pattern down column E, the last period with an actual series value is period 15, so that's the last period with a MA3 forecast error, again computed as actual value minus forecast value. Column F contains the magnitudes or absolute values of all the MA3 forecast errors, where the forecast errors appear in column E. The magnitude of these errors are obtained using Excel's absolute value function. When the column F entries are averaged, the MAD, or mean absolute deviation, measure of forecasting performance is obtained. The MAD is the most commonly used measure of model forecasting performance in time series analysis. MSE, as we studied in regression analysis, does provide an alternative measure of forecasting performance, but MAD is the most common for time series applications. On the next page, an example is introduced that's used through the remainder of the smoothing method discussion. The period is a week. There are 15 weeks worth of data. The data consists of the unit sales expressed in thousands of units. For example, the unit sales for the first week is 925,000 units. The time series plot appears relatively stationary. This is a good candidate series for smoothing methods. We have moved to the next page. On this page, you are asked to complete the entries on an MA3 model table using the methods we introduced earlier. You can pull down the text box to check your answers. Here is a simultaneous scatter plot of the actual unit sales data in blue and the MA3 centered smooth series values in red. Note that the smoothed series values change more slowly from week to week than do the actual series values. Note also that the smooth series does not have a value corresponding to the first period and does not have a value corresponding to the 15th period. Two series values are lost. Here is a simultaneous scatter plot of the actual unit sales data, again in blue, and the MA3 forecasts in red. Notice that the forecast errors can be viewed as vertical distances. For period 4, actual minus MA3 forecast is negative. For period 5, actual minus MA3 forecast is negative, and so forth. We in fact will have 4 consecutive negative forecasting errors. But once we get to period 8, the actual minus the forecast MA3 value is in fact positive, and actual minus forecast continues to be positive until we get to the 15th period, when once again it becomes negative. We can see these negative forecast errors and positive forecast errors in the MA3 forecast error column on the previous page. To do the homework, you need to know how to produce simultaneous scatter plots. The method is explained on the next page. We have moved to the next 2 pages. On this page, we fit an MA5 model to the weekly unit sales data. The pattern we developed for the MA3 model is essentially the same for the MA5 model, except we are averaging over 5 consecutive actual series values. The first MA5 smooth series value is identified with the 3rd period. In the MA5 model, we lose the first 2 periods. The last MA5 smooth series value, the average of the final 5 actual series values, is identified with the 13th period. We lose the last 2 periods in the MA5 model. The MA5 forecasting series is obtained by moving the entries in column C forward, this time 3 periods. So the first MA5 forecast is for period 6. Following this pattern down to the final entry in column D, we obtain the forecast for the period after the original series ends, period 16. We see that the period 16 MA5 forecast is just the average of the final 5 actual series values. The pattern for computing the MA5 forecast error, the magnitude of the MA5 forecast error, and the MAD is the same as for the MA3 model. On this next page, you are asked to apply the MA5 model to the weekly unit sales series. This exercise is similar to the exercise you completed earlier for the MA3 model. To complete this screencast, we offer a general result. In the general moving average model of L periods in length, a total of L-1 periods are lost in computing the centered smooth series values.